All right, thank you so much for the introduction. Our topic is, can we make FCC experts LLMs? And this is a joint work between Atul, Veronica, me, Jason, Lucy, and also Professor Surun. Okay, so picture this. You're just about to launch like the most revolutionary smartwatch the world's ever seen, right? Pre-orders, they're going crazy. Tech blogs, they're all over it. And venture capitalists, they're like throwing money at you. But then suddenly, boom, you hit a wall. A big, boring, bureaucratic wall. And it's got 3 letters on it. FCC. While the system design, like those required in a smartwatch, requires FCC compliance before it could be sold. But wait, here's the catch. These regulations, they're often lengthy, they're complex, and they're often inaccessible. So, do we know any tool that could deal with large amounts of text, like those in FCC? And yeah, it's already in the name of the title. It's large language models. And I'm pretty sure all of you know what a LLM is. So this will be a quick and non-technical and oversimplified introduction of LLMs. So you can think of LLMs like a super smart digital friend that has read tons and tons of books. It can understand what you write, process the information, learn the patterns, and then finally output like a human. And it's really similar to how us humans learn language. First, you collect the data, and this stems from all sources. For instance, like Stack Overflow for coding data, and also like books, posts, and blogs. Next, you put these data into training, and this is to predict and produce coherent responses. And then last but not least, it takes what it has learned to answer the questions from the user. And quick examples. So it can help you with writing, translation, math, and also explanation. And looking at prior LLM research, we found that this technology hasn't been applied to wireless regulatory expertise. While LLMs has shown success in several general domains, it haven't been applied to FCC regulation, which leaves a huge gap between AI capabilities and FCC expertise. And so, this is where we introduce our system. Will. Will is an open source personal FCC compliance assistant, and it's made possible by the power of LLMs. Will helps designers do fast compliance checks, so they have more time to do what's important, which is innovation. And it's also the first system to assist with FCC compliance. And it achieved a comparatively higher accuracy compared to off-the-shelf models. Wait, but you might be wondering, why should I use Will? Why can't I just use off-the-shelf LLMs for these FCC regulation questions? Well, let's take a look together, as if you do throw a question inside the naive LLM. So let's say you're the user. You give it a prompt. And the off-the-shelf LLM will answer somewhere along the lines of this. And you see the first error. It gives you a wrong mathematical output. And then you continue digging through the long response, and you would see another problem. It's missing crucial information. It only gives you which part of the FCC rules it derives its answer from, but there's many subsections within that part. So we needed to be more specific. So is this problem solvable? Well, now next, let's talk about RAG, or Retrieval Augmented Generation, because RAG was originally developed to address these exact problems. So what RAG does is it retrieves relevant information from a database so that it can produce a more accurate answer. However, previous RAG researches has focused on general Q&A domains. There's nothing related to FCC regulations or wireless domain technical documents. Therefore, for FCC compliance, we desperately need a customized approach, and therefore, we have the dawn of Will. Wait, but first, what is RAG, and actually, how does it work? Well, RAG is essentially giving it an add-on to an LLM, giving it more information to produce better answers. And it works like this. A conventional RAG system inputs you give it a corpus. So in our example is FCC documents. You split that document up into separate chunks, you embed that and store it into a vector database. And then according to what the user asks, there's a context retriever which retrieves the most relevant context and then combine it with a user query to produce a LLM response. Now, then you might be thinking, hold on, does conventional rep work well in our use case? Well, the answer is no. And according to our study, it has low precision while dealing with these specialized domains, such as FCC compliance. Now, let's take another look at the pipeline. And in our study, we found that one of the main problems lies right here, in the chunking algorithm. And however, due to time constraints, I'll be only talking about one of these chunking algorithms. There's many out there, but I'll be only talking about the recursive chunking. So what recursive chunking is let's say we have a section extracted from the FCC, and this is about Wi-Fi device power limits. What recursive chunking does is it splits up the text either based on character length or special characters such as commas or periods. So in this example, it gets split up into 4 different chunks. Now, let's say we ask a question regarding designing a UWB device. What recursive chunking does is it matches similar keywords with the chunks. So as you can see highlighted using the red boxes, chunk 3 and chunk 4 are the most relevant chunks. So therefore, the answer will be derived from chunk 3 and chunk 4. However, if you remember, these extracted chunks were originally used for Wi-Fi device power limits, but our user is asking UWB device design. Wait, so that isn't right. So the next logical question will be, how do we retrieve the correct context? And we drew inspiration from how us humans actually parse the data. So if you remember, if you read a book, first you start with the table of contents. You find that what subpart that you want, you navigate to that section, and then after you flip to that section, you then start reading the actual context. And just like a book, the FCC rules has really similar structures, such as subparts, sections within that subpart, more subparts, and yes, you guessed it, more sections. And so what our contribution is, we implemented hierarchical chunking on the FCC documents. We extracted the subparts, then we extracted the section, and these two together form the header or the metadata for each chunk. Then we append the actual context next to the header data. And these 3 together form a single chunk. So with our hierarchical chunking introduced, this is the new pipeline for Will. Now, how does Will answer to the same query as before? Let's take a look. So Will first answers with a simple yes or no as to whether this is compliant. Next, it gives you a SAP reference section as to where it derived its answer from. And last but not least, it appends the reasoning or the why it gave an answer like this. And when we tested different chunking strategies using ChatGPT-4 as our base model, we found that recursive character and sliding window chunking techniques both achieved around 62% accuracy. In contrast, our hierarchical chunking approach achieved 78.6% accuracy. We do recognize and acknowledge that this is still a huge gap between 100%, but we believe that this is a huge step towards the right direction. And for future researches, we hope to further increase this accuracy. And this is the accuracy for Will compared to other off-the-shelf models. Llama achieving 35%, GPT 3.5 achieving 46%, GPT-4 achieving 73%, and our Will achieving 78%. And one of the reasons why Will has a 20% error rate is due to our limitation to data sets. Right now, we only have 60 Q&A pairs, And this is, in the future, we hope to create a larger data set using either synthetic data generation or by another LLM. And the reason why we only have 60 Q&A pairs is because creating this Q&A pair requires extensive manual labor work. And all these Q&A pairs were derived from a wireless expert. While we only focus on FCC compliance, this work represents only the tip of the iceberg for mobile systems research. The same concept could be applied to many other domains. So for instance, security guidelines, protocol standards, and so much more. To conclude, we'll achieve a high accuracy through our hierarchical chunking approach. And to our best knowledge, this is the first ever system to assist wireless system designers with FCC rules. And through our research, we just made this expertise more accessible to system designers. And last but not least, we have open sourced this code. So feel free to try it out. The QR code is on the bottom right. And thank you. This is my presentation.